Okay, I do want to talk about Homegrown National Park today and how, if we actually create it, it's going to build networks that support life in our human-dominated landscapes. But before we talk about that, let me ask you what this is. Kind of looks like a fecal sac. You know, when birds are raising their young, they don't want their babies to poop in the nest, so they've evolved this little sac. They poop into a sac and then they fly out and just drop it and it goes splat. And that's what this looks like. But it's actually a spider. It's a bulla spider. It's sitting on top of the leaf uh, because it wants to look like a fecal sac. Nothing wants to eat a fecal sac. But at night, it looks like a real spider. It hangs from a leaf and drops a single strand of silk with one sticky glob of glue at the end there, and then it goes hunting. Now, you wouldn't think it would catch anything with a single strand. You think a web would be a better approach. But it does. It catches moths. Moths fly in. As soon as they get attached to that glob of glue, the spider spins them around, wraps them up in silk, and then has a good meal. Then she cuts it loose and goes hunting again. And she catches another moth, and then she catches another moth. And when she's had enough energy from these moths, she makes an egg sac in a very ornamental um, silken pouch. That's how the spider spends the winter, as eggs. And if she catches enough moths, she'll make 2 or 3 egg sacs and just hang them all in a row. Well, the real question is, why are moths flying into this one target? Turns out it is not by accident. She's releasing the sex pheromone of that particular species of moth. So all the moths that fly in are males because they think she's a female. She is, but she's the wrong species. So I wanted to know, I was interested in what species of moth the bulla spiders at my house were attracting. So I unwound the little bodies that were on the ground, and I found out it's the bronze cutworm. And I've got bronze cutworm adults because I've got bronze cutworm caterpillars, and I've got bronze cutworm caterpillars because I've got goldenrod, which is their primary host. I also have this beautiful moth, the dot line white, because I've got oak trees, primarily white oak trees, and because I don't rake the leaves away from under those oaks. There is a dot line white cocoon in this leaf litter, and you're never going to see it when you're raking. It's right there. If we enlarge it, it's right there, but they blend in really well. So this is one of the messages of today. If we rake our leaves away, we're throwing away a lot of the life forms that could be on our properties. I have this beautiful moth, the evening primrose moth, because I planted evening primrose. The moth did come. It spends the day with its head stuffed in the flowers like this, and sometimes it's crowded, but it's always very beautiful. I've got even more beautiful, the zebra swallowtail, because I planted pawpaws. That is the only plant that the caterpillar of that swallowtail can grow on. So it would take me a long time to describe all of the species that are now making a living at our property because we put the plants that they require there. It would not take me very long to describe what's living on a typical residential landscape. There is no goldenrod in a typical residential landscape, so there's no bronze cutworm, so there's no bulla spiders. If you don't have white oak trees, you're not going to have the dot line white. If you don't have evening primrose, you're not going to have the evening primrose moth. If you don't have pawpaws, you're not going to have zebra swallowtails. In fact, there's very little that can live in a typical residential landscape. And we've got 135 million acres of typical residential landscapes in the US, and we are not through. We're still developing 800,000 new acres of natural areas every single year in the US. And that's one of the reasons we're seeing some pretty scary headlines these days, like the insect apocalypses here, talking about global insect decline. North America's lost 3 billion breeding birds in the last 50 years. That's a third of our North American bird population already gone. 2/3 of Earth's wildlife is already gone. 40% of the Earth's plants are facing extinction, and the UN says we're going to lose 1 million species to extinction in the next 20 years. All these have happened except this one. This is a prediction, and it's a prediction we have to make sure does not happen because these are the species that keep us alive on this planet. It's real bad news, and that's why Elizabeth Colbert gets to write this book, The Sixth Extinction, talking about the sixth great extinction event that the Earth has ever experienced. But this is the first one to be caused by a living being, and that, of course, is us. This is not a prediction. We are in the middle of it. It is happening right now. Well, people are upset about this, and I'm glad they're upset about it because that means we're going to do something about it. They're so upset about it that scientists are actually studying what our reaction is to the loss of biodiversity. And one of those scientists is Richard Hobbs. And he thinks that our response to biodiversity loss is very similar to the 5 stages of grief that we experience when we hear we have a terminal disease. There's first denial, very common. We got a lot of denial out there. Oh, we don't really have a problem. Anger, I feel that sometimes. Bargaining, well, maybe we can do this, maybe we can do that. Depression, I also feel that. Stage 5 is acceptance. And here we have to push back because acceptance is the same thing as giving up, and giving up is not an option. We cannot give up on nature because nature is not optional. It's essential to our own survival. So I'm going to propose stage 6, and that is action. We really can do something about biodiversity loss. Now, we do have parks, particularly national parks. We've got preserves. These parks were established primarily because they were exquisitely beautiful. And Teddy Roosevelt had a lot to do with expanding the National Park Service. And this is what he said about it. The establishment of the National Park Service is justified by considerations of good administration. So Teddy was patting himself on the back, as he should, of the value of natural beauty as a national asset, and of the effectiveness of outdoor life and recreation in the production of good citizenship. In other words, our parks were created because they were pretty places for us to play in. And that's okay, but they were not created with conservation in mind. And that's one of the reasons we only have 3.6% of the US in national parks. Only 12% is federally protected. How does that compare with Costa Rica? Tiny little Costa Rica, it's got, what, 25% of its country federally protected. So we could do better. We could do better. We do have parks, we do have preserves, and people wonder why they are not good enough. Why are they working to preserve our biodiversity? It's an excellent question. And the answer is there's actually several reasons why they're not working, but the big one is that they are too small. When you take a large habitat like this and you shrink it down to a little habitat fragment, and this is an exaggeration, you're taking large populations and shrinking them down to small or tiny populations. And that is the problem. Small populations are highly vulnerable to local extinction. Why is that? Well, because all populations fluctuate. In good times, they go up, and bad times, they go down. If you're a large population, like this top line here, even in your down cycle, there's enough individuals that you can increase quickly when times get better. But if you're a tiny population, often in your normal cycles, you hit zero. You blink out of your little habitat fragment, and then you're gone. And unless you recolonize that habitat, you're permanently gone. That is called local extinction. And recolonizing habitats these days is harder and harder. Imagine a box turtle crossing Route 95. Just it's not going to happen. There are studies all over the world, and some of them quite lengthy, over 100 years in length, telling us the same thing. The natural areas that we've left on the planet are not large enough to sustain the amount of nature that we need to sustain our huge human populations. Now, we tend to use extinction as a metric of trouble. We got the Endangered Species Act. We don't want things to go extinct, and we don't want them to go extinct. But I think that's the wrong metric. That's like going to the doctor when you're dead. It's too late. So I'm going to propose that we talk about something called defaunation. It's the reduction in the abundance of species that were once common enough to run our ecosystems. They're not extinct, but they're no longer numerous enough to perform their ecosystem roles. This is the American chestnut. It's a perfect example of defaunation. Of course, when we brought in the chestnut blight in the early part of the 1900s, it essentially took out all of the chestnuts from Maine all the way down to Georgia. It was a dominant tree along the Appalachian crest, and it ran that ecosystem. So again, it's not extinct. Little sprouts come up from the roots every year, but it is no longer performing the roles that it once performed, and it's been a huge loss to our eastern forests. This is the rusty patch bumblebee. It used to be one of the most common bees in the country not that long ago. But today, if you find one, it's a big deal because they are on the brink of extinction. Not extinct yet, but they're functionally extinct. They're no longer performing their roles in their ecosystems. The American beaver, it's not extinct either. But When Europeans came to this country, beavers were everywhere. They established the hydrology from coast to coast. We essentially trapped all of them out. A few remained, and now you can find beavers here and there. But every time they act like a beaver, we trap them and move them someplace else because we don't want them to mess with our hydrology. So the hydrology of the entire country is still changed because of the lack of beavers. So defaunation, the reduction in the abundance of species that run ecosystems, is the real problem. It's local. It's everywhere. Think about the species you encounter when you walk out your front door. Not very many of them. And we tend not to notice it. And we tend not to notice defaunation because of something called shifting baseline. It's normal for us to think that the way things were when we were kids is the way they've always been and the way they always should be. It's normal to us. None of us missed the passenger pigeon because it was extinct before any of us were born. It was the most common bird on the planet. So shifting baseline means that we're losing the biodiversity that sustains us, and we don't even notice it. Edwin Way Teal, you may remember him. He wrote extensively in the 50s and the 60s. He said that we cannot make the world uninhabitable for other forms of life and have it habitable for ourselves. That's such common sense, we tend not to even realize this. It amazes me when I just think about that. So what are we going to do? We have to do something. There's actually some good news. The biodiversity crisis is getting headlines now. The UN had a big meeting last year in Montreal to discuss the biodiversity crisis. Now, what does the UN do? It makes resolutions. What do? We ignore those resolutions, but at least they're talking about it. This was a headline that came out of that meeting. Crucial negotiations to protect biodiversity are moving at a snail's pace. We are negotiating whether or not we're going to protect the stuff that keeps us alive on this planet. I just shake my head. So I'm not gonna rely on UN resolutions to do much. How about if we listen to what E.O. Wilson told us? The late E.O. Wilson. He died the day after Christmas 2 years ago. Extremely long career at Harvard. I'm going to call him the most famous professor that Harvard produced, at least in the last century. And one of the things that was consistent throughout his very long career was his love of life on planet Earth and his efforts to save them. He wanted to save biodiversity, not just because he loved it, but because he knew it was essential to our own survival. So in 2016, he wrote this book, Half Earth, Our Planet's Fight for Life. And he had one simple message. He said, if we don't save nature, if we don't save functional ecosystems on at least half of the planet, life is going to disappear everywhere on the planet, and that includes humans. So it's a very bold statement, and he spent most of the book talking about the science that supports that very bold statement. And then he ended the book. He did not spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, to a conservation biologist, that's good news. We'll just put half the Earth aside, and all those things that are in trouble can be in that half. We humans can be in the other half, and it'll be great. Problem is, half of terrestrial Earth is already in some form of agriculture, and I don't see that changing very quickly. And of course, we've got 8 billion people, and all of our roadways and airports and detritus in the other half. And we don't have a third half to put aside for nature. So how can we realize E.O. Wilson's dream? Well, I actually think we can, but we need a new approach to conservation to do that. We've got to give up the idea that humans and nature cannot coexist, that we cannot live together in the same place at the same time. That's been our philosophy forever, and that's got to change. It's got to change because not only is living with nature an option that we haven't explored, it's now the only viable option that's left to us. In the past, of course, conservation has worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. So we're not just going to practice conservation in areas like this. We're going to practice it over here. But look, there's nothing to conserve over here. So we have to move beyond conservation. We have to move into restoration. We have to rebuild it. We have to rebuild it where we live, where we work, where we farm, where we play, pretty much everywhere. And that means we've got to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, but thrive. So this has been discussed as the major problem: fragmentation. We've fragmented our ecosystems into tiny little habitat fragments that are small and isolated from each other. So the solution that's been proposed is to build biological corridors that connect these isolated habitat fragments with each other, so the plants and animals can move back and forth between viable habitat. And I'm sure that's a good first step, because first of all, if we have exchange of genes, then we won't get inbreeding depression when things are isolated in one tiny habitat. But the major problem remains. The habitat itself is still tiny, so the populations within them are still tiny, and when they fluctuate, they will still disappear over time. So I do not see this as a permanent solution. What we need to do is rebuild viable habitat in between the existing habitats. Right now, this is no man's land. We're not going to build just roadways where the plants and animals can move back and forth. We want to build viable habitat by putting the plants back. So this is better. This is even better. The light areas here where there's not that many plants will be our cities and some of our farms. But what is this space? This is private property. This is where we live. We're going to put the plants back where we live, where we work, where we farm, all of those places. And that means we need a new attitude towards property rights. We've got this idea that takes a lot of hubris, but we think we can own a piece of the earth and we have the right to do whatever we want with that piece of the earth. This is our castle and we're the kings. We have the right to do whatever we want. Nobody can tell us to do otherwise. The problem with that idea is that our yards are not like Las Vegas. You know that what happens in Vegas stays in Vegas. Well, what happens on our yards does not stay on our yards. That is the big problem. Every one of our properties is part of the local ecosystem. So whatever we do on our property is going to impact that ecosystem either positively or negatively. Let's just look at what happens when you have a large lawn. The amount of lawn you have is going to determine whether rain infiltrates when you have a rainstorm or whether it leaves as stormwater runoff. And when it leaves a stormwater runoff, it's going to carry nitrogen and phosphorus and herbicides and insecticides and all that stuff we put on our lawns into the local watershed. The amount of lawn you have is also going to determine how much carbon we're adding to the atmosphere every time we mow. That's not going to help climate change very much. The amount of lawn you have is going to determine whether you're helping pollinators or not. If you follow the rules and you have a lawn that is simply grass, it doesn't help pollinators at all. The plants we have in our yards are going to determine whether we're actually helping climate change by storing carbon, removing carbon dioxide from the atmosphere. That's what plants build their tissues out of, the carbon from carbon dioxide. And then they pump the extra carbon that they fix through photosynthesis into the ground through their root systems. And once it's in the ground, it can stay there for thousands of years. It's extremely stable. But that depends on which plants you choose for your yard. The plant choices you make for your yard are going to determine whether you're harboring ecological tumors like Callery pear or Bradford pear or privet or barberry or porcelain berry or burning bush. All of these invasives that we've brought in that escape our properties and then they biologically pollute, they ecologically castrate the local ecosystems by pushing out the native plants that actually support the life around us. And then finally, the plants we choose for our landscape are going to determine whether we have a viable food web on our landscapes, whether we're choosing the plants that support the insects that the birds need to feed their young, and so many other food webs associated with plants. It all depends on which plants we choose. So in short, how we landscape, how much lawn we have, and the plant choices we make are going to determine how much life our properties can sustain. And if you add all those properties together, we're determining how much life Earth can sustain. And that is an awesome responsibility. And that is an awesome responsibility that homeowners, that property owners everywhere don't know they have. But it also creates what I'm calling a grassroots solution to the biodiversity crisis, because there are millions of us. There are millions of us. Each one of us can become the future of conservation because we're the ones that own the private property that comprises most of the country. 78% of the lower 48 states is privately owned. 85% of the country east of the Mississippi is privately owned. The future of conservation is going to be on private property, and that makes private property owners the hope and the future of conservation. Again, another awesome responsibility and another one that they don't know they have. Let's return to lawn. It is the low-hanging fruit. It is something we can manipulate on our yard the easiest, and we've got a lot of it. Last figure I saw was 44 million acres nationwide. That is an area bigger than all of New England combined, dedicated to an ecological deadscape. Why do we do that? Well, it's a status symbol. And I guess the more lawn you have and the more perfect it is, the higher status you have. And we have to display our Halloween decorations. But what if we cut the area of lawn that we have in half? We're not going to get rid of lawn. It's the perfect plant to walk on. It's a cue for care. It can still be our status symbol, but let's reduce the area that we have. Let's make the math simple. Let's say we've got 40 million acres. We're going to cut that in half. That'll give us 20 million acres that we can restore right at home, which is enough to make what I'm calling Homegrown National Park. And it'll be big. It'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. You add up all those parks, still less than 20 million acres. So Homegrown National Park will be the biggest park in the country. This is what we call the biodiversity map. This is a real thing now. We're a small nonprofit, so you can go to our website, homegrownnationalpark.org, and register your property on the map. You simply register your location and the amount of area that you are being a good steward of. Maybe you really are going to reduce the area that's in lawn. Maybe you're going to plant an oak tree. Maybe you're going to put an aster in a flower pot. It all counts. So you put that area on in the database, and then your little piece of your county will light up. And you're going to get to see how many other people in your county have joined Homegrown National Park. And of course, the goal is to get everybody to join Homegrown National Park. We want the whole country to light up. So our mission is very simple. We want to motivate millions of people to regenerate biodiversity right where they live by planting natives, by removing invasive plants that are on their properties. Most people have them and they don't even know it. And in so doing, building a community culture that is sympathetic to the needs of conservation. What are the ecological products associated with Homegrown National Park? Well, there's a significant increase in biodiversity right on our properties. And I'll give you examples of how well that works later on. A measurable reduction in invasive species. Now, if everybody got rid of the invasive plants just on their property, we'd be 78% done. We'd be 85% done in the east. That's a good first step. Significant drawdown of atmospheric CO2. Lawn, turf grass, is the very worst plant for sequestering carbon, for pulling carbon out of the atmosphere. If you replace it with anything else, and this would be a great example, you're going to be helping climate change. You're going to sequester a whole lot more carbon than your lawn is doing right now. And you're also going to create viable habitat. Remember, any bit of conservation we do outside of a park or preserve helps conservation inside of that park. There are also important sociological products that, in my view, are just as important. National awareness, not just of what the problems are, but what the solutions are and what our roles in those solutions are. We're trying to change the culture. We want people to recognize that nature is not optional. It is essential. It is essential for everybody, and that means everybody owns responsibility to sustaining it. We want to convert hope into action. Hope is good, but action is even better. Excuse my misspelling here. It's convert, not covert. And we want to merge all of the existing conservation organizations, Audubon and National Wildlife Federation and Wild Ones and all the land conservancies. We want to get them all registered on the map so we can see how well we're doing towards the 30 by 30 initiative. You know, the UN said that's one of the resolutions they made. We're going to save 30% of the planet by 2030. The Biden administration has accepted that challenge. Going to save 30% of the US by 2030. That is not going to happen if we don't record conservation on private property. And Homegrown National Park is free. We exist totally based on your generation. So thank you very much. There is urgency in enacting the Homegrown National Park solution. Remember that 135 million acres in residential landscape? That's a big job. So we all need to get to work. We only get to work right away, but we have to understand what it is we're supposed to do. How do we know what to do in order to succeed? Well, let's talk again about the 4 goals that every single landscape has if we're going to reach a sustainable relationship with planet Earth. Every landscape has to support a viable food web. If we don't have viable food webs, we don't have functional ecosystems. Every landscape has to sequester carbon. It has to pull carbon out of the atmosphere, put it in their plant tissues, and then pump it into the ground. Every landscape has to manage the water in which the watershed in which it exists. Every single landscape exists in a watershed. This is a neighbor down the street, and you know he doesn't know it, but he is destroying my watershed, and he doesn't really have the right to do that. And every landscape has to support the pollinators that pollinate 80% of all plants and 90% of all flowering plants. We talk about lawn because lawn accomplishes none of those goals. Absolutely none of those goals. None of the ecosystem services we need are produced by our lawns. Plant choice, extremely important. This is burning bush, of course, major invasive species. The plants we choose for our yards are going to determine much of what I just talked about. There are 3 kinds of plants out there. There are plants that contribute energy to local food webs. There are plants that do not contribute energy to local food webs. And there are plants that remove energy from local food webs. The very best contributor to food webs across the country, in 84% of the counties in which they occur, is one of our oaks. Oaks are contributing more energy. What do I mean by that? I mean, they are capturing energy from the sun and through photosynthesis, turning it into the food that supports just about all the animals on the planet. That's what plants do. If you don't pass that food on to animals, you don't have any animals, then you don't have a food web and you don't have a functional ecosystems. Well, oaks are passing on more energy than any other type of plant. Ginkgos, Ginkgo biloba from Asia. It's a good ornamental plant, pretty in the fall. But nothing eats a ginkgo, so it's not adding any energy. It's not sharing any of the energy that it captures from the sun. So it's a non-contributor. And a good example of a detractor would be any of the non-native ornamentals that have escaped our yard and the major invasive species around the country, privet and burning bush and bush honeysuckle. This is bamboo. Not sharing any of its energy, but when it escapes, it pushes out the native plants that do. So it actually removes energy from local food webs. Another thing we have to do is to start for the very first time appreciating how important caterpillars are. You know, as gardeners, as landscapers, we tried to kill caterpillars forever. Not good, because caterpillars are what is driving our food webs. Caterpillars, it turns out, are transferring more energy from plants to other animals than any other type of plant eater. It turns out that vertebrates don't eat plants directly, most of them. Most of them eat invertebrates that eat plants, and most of those invertebrates are caterpillars. So if we landscape in a way that does not include a lot of caterpillars, which is the way we currently landscape today, then you have a failed food web and eventually a failed ecosystem. And that's why I talk about keystone plants so much. Keystone plants are the plants that support the most caterpillars. They are adding the most caterpillars to our food webs. Remember what a keystone is. It's the stone in the middle of the Roman arch, and if you take that stone out of the arch collapses. Well, if you take keystone plants out of your local food web, the food web collapses. And that's because just 14% of our native plants, the keystone plants, are supporting 90% of the caterpillar food that drives our food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s that support that house. They are the support system. They're not optional. You can't build a house out of wallpaper, and that's what we've been trying to do for the last 100 years with our ornamental plants. So what is the best keystone plant where you live? Well, you can find out by going to Native Plant Finder, and I will put this up at the end of the talk. Native Plant Finder and the National Wildlife Federation website. Put in your zip code, and the ranked list of the most important woody plant genera and herbaceous plant genera in your county will pop up. Now, these lists change as you move around the country. And this is abbreviated, just ran out of room. But the old excuse of not knowing what to plant to support wildlife is just an excuse now. You do know what to plant. Just go to Native Plant Finder and put in your zip code. Another thing we have to think about, or at least remember, is that most of the insects that are eating plants are host plant specialists. They can only eat particular plants. They can only eat the plants for which they have specialized adaptations that allow them to get around the plant defensive systems. They have specialized enzymes that store and excrete and detoxify plant defenses, behavioral adaptations and life history adaptations that minimize the insect's exposure to all those plant defenses. But once it takes a long period of interacting with plant lineages for all those adaptations to fall into place. And once they do, the insect is locked into eating that particular plant. Let's use the monarch butterfly as an example. I use the monarch because we like monarchs, and we also know a lot about them. We know they are host plant specialists on milkweed, and we know that milkweeds are toxic plants. So if you have the habit of walking around your yard and eating plants, don't eat a milkweed. It's filled with cardiac glycosides, and if you eat enough milkweed, it will stop your heart, and we don't want that. Milkweeds, of course, are also loaded with sticky latex sap. That's what gives them their name. If you break open a milkweed vein, all this white goo comes out, and if you get it on your finger and just hold it there for a minute or two, you'll see that it gels. On exposure to air, to oxygen, it becomes like chewing gum. And that's its defensive property. If a caterpillar gets this on its mouth parts, it glues the caterpillar's mouth shut, and then it starves to death. So how does a monarch butterfly caterpillar eat milkweed without gluing its mouth part shut? Well, this is something you can watch right in your yard. You just have to plant milkweed, watch the caterpillar walk onto a leaf. The first thing it will do is go to the end of the leaf and start to eat. And if any latex sap starts to come out at all, it will stop eating immediately, turn around, go back up the leaf, maybe 2/3 of the way, and start to chew through the midrib. And it will chew and chew and chew until it has completely severed the midrib. And what that does is block the canals that shunt the latex sap from this part of the leaf down to this part of the leaf. And all this part of the leaf then becomes edible. So it turns around, goes back down to the end of the leaf, and it can eat the leaf without any latex sap coming out at all. That behavior also flags the leaf. So it enables you to find whether or not your milkweed patch has monarch caterpillars very easily. You can even drive down the road and look at a milkweed patch. And if there's any flagged leaves, you know that monarchs either are there or have been there recently. So those are the upsides of specialization. The monarch has the adaptations that allow it to eat a toxic plant that most other insects cannot eat. They've got the physiological adaptations and the behavioral adaptations. The downside of specialization is that now monarchs are locked into only eating milkweeds. Out of the 2,137 plant genera in North America, monarchs can only eat one, the genus Asclepias. So if we take Asclepias out of our yards, you don't have any monarchs. It can't start eating our hosta or anything else. And monarchs are not exceptions. 90% of the insects that eat plants have specialized relationships with particular plants. We have to listen more carefully to what E.O. Wilson told us. He told us these things throughout his life. He's gone now, but his wisdom remains, and we have to pay closer attention to it. One of the things he said is insects are the little things that run the world. That's a pretty important statement. He said, life as we know it depends on insects. And if they were to disappear, so would most of the flowering plants. And if most of the flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals would collapse. The amphibians, the reptiles, the birds, and the mammals would all disappear if we lost our flowering plants. The biosphere, the living portion of the earth, would rot because it would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And humans wouldn't survive any of those drastic changes. We have to pay closer attention to pollinators than we have been. Now, we're actually doing pretty good on this. Colony collapse disorder in honeybees, it's probably been 20 years now, has alerted us to the fact that our pollinators are in trouble. But we've got this notion that we need pollinators because they pollinate a third of our crops. We actually need pollinators everywhere, not just in agriculture, because they pollinate 80% of all plants and 90% of all flowering plants, including a few of our crops. If we lost our pollinators, we'd lose 80 to 90% of the plants on the planet, and that is not an option. I've heard people say, I don't live next to a farm, so I don't need any pollinators. Nonsense. We need pollinators everywhere. We need plants, which is everywhere. We have to start to appreciate how important leaf litter is. Gene Ponzi in St. Louis calls it leaf largesse, because it's not litter. It is an extremely important component of our terrestrial ecosystems. There are two major things that leaves do that we lose if we rake them away. One is they form a blanket over our soil community. Everything that lives in the soil, and there are more species that live in the soil than above the soil, depends on high humidity. The blanket that leaves a form over the soil keeps the moisture in the soil. So when we go through a period of drought, if you remove the leaves, the soil dries out right away, and you lose all your decomposers. You lose the mycorrhizae that transfer nutrients to our tree roots. The soil community collapses. So keeping the leaves on the soil is very important. The second thing leaves do is return the nutrients that your trees use that year to the soil so that your trees can use them again. It creates a closed nutrient cycle. If we rake our leaves away or burn them or just remove them, you're starving your tree. If you do that for 50 years, no wonder our trees don't live nearly as long as they used to. And people worry, well, if I have to rake my leaves away because my plants won't grow if I don't. Well, who was raking the leaves before we got here? Nobody. And we had a lot of nice plants. As a matter of fact, it looked a whole lot nicer than it does right now. Our plants are actually very good at getting through normal layers of leaf litter. So don't worry as much about that. We have to appreciate how important light pollution is. It is one of the major causes of insect declines. And fortunately, it is the easiest one to mitigate, to reverse. Light pollution, these are all the ways that lights kill our insects at night, particularly the moths that create those caterpillars that run the food webs that we depend on. But I think it's good news because we've got to stop insect decline. The latest figure is that we've lost 75% of the insects on the planet. Remember E.O. Wilson? They're the little things that run the world. That's not good. So we've got to reverse that, not just stop it. We've got to reverse it. And if we can do that by flicking a switch, we're getting off easy. There are a lot of switches to flick, but there's a lot of us to flick those switches. Well, one of the things that people complain about is I can't turn the light out over my barn or over my garage or over my front porch because the bad man will come. All right, put a motion sensor on your security light so it only turns on when the bad man does come. And believe me, the bad man does not come very often. Even easier is to take the white bulb out of your security light and put in a yellow bulb. You can buy these at the hardware store. Yellow wavelengths do not attract nocturnal insects. It is the easiest environmental problem to solve. If we took out our white bulbs and replaced them with yellow bulbs overnight, we could save millions of insects. And if we used LEDs, we could save millions of dollars as well. Mosquito fogging, booming business around the country. And they say it's okay, do not worry about it, because what we're fogging is an organic natural product. And they are correct. It is an organic natural product made by chrysanthemums, evolved in chrysanthemums to kill insects. But you know what? Cyanide is an organic natural product. Ricin is an organic natural product. Nicotine is an organic natural product. Plants make lots of organic natural products that are highly toxic. They also say, and I wish they were right about this, that it only kills mosquitoes, but they are not right. It kills all the insects it comes in contact with, including our poor beleaguered monarchs, which are now red listed. We have the second smallest monarch population this year on history. This was the result of a mosquito fogging event on Kent Island and in the Chesapeake. My friend happened to be there, and he picked up this handful of dead monarchs, but he said there were thousands on the ground because it was during a monarch migration event. So the fogging kills the monarchs. It kills the pollinators that we're trying to save. The interesting thing is it does not control mosquitoes. We are killing all these non-targets for nothing. Actually, you pay a lot of money to kill all those non-targets. Why doesn't it control mosquitoes? Well, because you don't control mosquitoes in the adult stage. You have to kill 90% of them to get good control in the adult stage. These guys kill between 10 and 50%. So they have to keep coming back and back and back, killing the monarch over and over again and the pollinators over and over again. If you really want to control monarchs, do it through biological control. Get a bucket, fill it full of water, put in a handful of straw or hay, put it out in the sun for a few days, and that will build up the population of diatoms and algae, and that is what mosquito larvae eat. So that brew becomes an irresistible brew to any female mosquito that's in your yard. She will preferentially lay her eggs in your bucket. Then you go to the hardware store and you buy a sheet of mosquito dunks, $12 for a season's worth of control. This is Bacillus thuringiensis. It's a natural bacterium that only kills aquatic diptera, and the only aquatic dipteran in your bucket is a mosquito larva. So you take your dunk, you put it in the bucket, and you kill the mosquito larvae. It's targeted. It only kills mosquitoes. It's cheap, and it is effective, particularly if everybody does it. We have to start to appreciate that small yards can be important in terms of conservation. This is just one example. This is Pam Carlson's house in Chicago. It's 1/10 of an acre. That's 3 times smaller than the average lot size in North America. All native plants here, except for the lawn, which is a nice cue for care. But she's recorded 125 species of birds that have used her yard. If you don't have a yard, you still have conservation opportunities through container gardening. If you put the appropriate native plants in containers on your porch or on your balcony, you're going to help a lot of native bees that are highly mobile. They can fly up too. And you help the migrating monarch as well. So imagine, here's an apartment complex. Imagine if each one of these porches had container plants on them. You would turn a pile of bricks into a valuable resource for any urban pollinators that are out there. What plants should you put in those containers? Go to our website, homegrownnationalpark.org, and there is a section of that website that talks about the appropriate native plants in your ecoregion for containers in urban settings. Now, fortunately, we do have a silver bullet in our fight against climate change and biodiversity crisis. The 2 major environmental crises facing us today can be solved, at least partially, in the same way. And that is through conservation. Conservation works. Here's for one example. Nachusa grasslands, 3,800 acres in Illinois. More than 730 plant species there now. 180 species of birds are using this place. It used to be a cornfield, and it didn't take that long. Nature is resilient. It will rebuild itself if we give it half a chance. This is where I live, where my wife and I lived, Cindy. We moved in, this is what it looked like when we moved in the year 2000. It was part of a farm that was broken up into 10-acre lots, very old farm, been farmed almost 300 years. And the last thing they did was mow it for hay. So there were no trees there. It was really a pretty depauperate place. And our goal was to put it back together again. Well, we live in Southeast Pennsylvania, and if you mow for hay in Southeast Pennsylvania, the area is totally invaded by non-native plants. And what you're really mowing is the rootstocks of all of those invasive plants from Asia. So when you stop mowing, which of course they did when we bought the property, this is what comes back. It's just a giant tangle of Japanese honeysuckle and bush honeysuckle and multiflora rose and oriole and bittersweet and all of those things. Which means before you start your conservation, you've got to get rid of that stuff because they're not going to support the local food web. It is not as hard as you think. You just get your wife to do it. And when she's finished, you can put the appropriate native plants back. And this is just an example of what our yard looks like in the summertime. We're still adding plants. We're not done yet. But so how effective is this? I've been counting the moth species that are now making a living on our property because we put the plants back for the last 6 years. I've been taking a picture of every species of moth that I could find. I am still at it. But I'm up to 1,262 species of moths that live here now because we put their host plants back. Now we have 10 acres. Pennsylvania is 22.9 million acres. So on one tiny sliver of Pennsylvania, we've got 48% of all the moth species that occur in the entire state. And many of these are really cool creatures, like the chinkapin leaf miner. They've got great names, too. The skullcap skeletonizer, the neighbor, the little devil, the horrid zale, the forgotten frigid owlet. I feel so sorry for him. The visitation moth, the obtuse yellow, the explicit arches, and yes, there is an implicit arches, the snowy shouldered aclaris, the grateful midget, the morbid owlet, the pink-shaded fern moth, the feeble grass moth, the scribbler, the lemon plagotis, the cynical quaker, the showy emerald, the green marvel, Harris's three-spot, the old wife underwing, the eyed pectes, the hog sphinx, the tufted bird-dropping moth. Who wouldn't want the tufted bird-dropping moth? And this is I think the most beautiful, the spun glass caterpillar. And literally hundreds of other species have come to the plants on our property. And the first thing people say is, well, why don't they eat all your plants? How do you have any plants left? Remember, these guys are the meat and potatoes of local food webs. They've got a lot of things that are eating them, and it keeps them in control, like birds. We've recorded 62 species of birds that have bred on our property because we've got the caterpillars that they can use to feed their young. Without those caterpillars, no breeding birds. We also have a lot of insects that are eating those caterpillars, like ambush bugs, like assassin bugs, like predatory stink bugs. This guy sat next to this aggregation of milkweed tussock moth, and it ate one every time it got hungry. So the aggregation got a lot smaller over time. We've got a lot of hymenoptera and parasitoids that are laying eggs in caterpillars. This is actually the major cause of caterpillar population control. We've got other species of wasps that sting the caterpillars and paralyze them. And then they carry them off and put them in their nest and lay an egg on it. This is nature's form of refrigeration. If they killed the caterpillar and carried it off and laid an egg on it, the caterpillar would rot before the egg even hatched. But when you paralyze it, it stays a nice viable piece of food. Then the egg hatches and can eat the caterpillar. We've got a lot of vertebrates that eat our insects and keep them under control. We've got a few skunks. Actually, I've only seen one. We've got possums, we've got raccoons, we've got foxes. 25% of a red fox's diet is insects. We've also got amphibians like the spring peepers. We've got toads. We've got salamanders. We've got ringneck snakes. We've got the cutest little gray tree frogs that are actually green when they're little on our property. Lots of things keeping those caterpillars under control. That's called a balanced food web. Oops. Now there's something in common. I don't know what's happening to my computer here. There's something in common to all of these conservation approaches. And that is whether or not they succeed is going to depend on the decisions that you and I make. They become people problems, not scientific problems, not biodiversity problems. They're people challenges. Amanda Crandall was a student in my class a few years ago, and this was part of a final exam answer she wrote. She said, Well, conservationists claim to be managing species and habitats. What we're really managing is people. So true. We need to change the adversarial relationship that so many of us have with nature to a collaborative one. That is a sociological challenge. And the question is, can we do it? Well, I think we can. I definitely think we can. It doesn't mean you have to save biodiversity for a living, but you can save it where you live. And if you do, it empowers you. You know, right now, an awful lot of people realize the Earth's got some serious problems, but they feel powerless. What can one person do to help the entire Earth? Well, one person can shrink the lawn, one person can modify their lights, one person can add a pollinator garden, one person can remove invasive plants from their property, one person can use keystone plants, one person can fire Mosquito Joe. There's a whole bunch one person can do to revitalize the ecosystem right where they live and then enhance their greater local ecosystem. And it shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. You will get depressed. Just think about the piece of the earth that you can influence. If you own property, it's obvious. That's where you start. If you don't own property, help somebody who does. Help a land conservancy, help a park or preserve. They're all underfunded. They're all understaffed. They will love you as a volunteer. So I hope that Homegrown National Park will provide the motivation and the guidance. There's a lot of information on our website and the community for millions of people to tackle these conservation problems. Because whether or not we do so now is going to determine nature's fate and then ultimately our own. And I want to leave you with the Homegrown National Park Challenge. If you can, it would be wonderful if each one of you planted a single keystone plant this year. Like Mr. Stellar's J is doing here with an acorn, take you 5 minutes. And you might think that's not going to make a big difference, but I want 400,000 of you to do that, and that will make a big difference. So there are those websites that I mentioned earlier. You can copy them down at your leisure, and that is all I have. Thanks very much.
Wow. What a gift. Doug, you are just an inspiration all around. A big round of applause that you can't hear, but hopefully you can see. We've got 81 people cheering you, Doug.
Oh, good.
Michelle, would you like to take questions since you're much better at seeing where we have someone with a question? Yes. Anything that would stand in anybody's way that you'd like to tackle on your own campus or on your own porch at your summer place?
Absolutely, Mary. And I'm going to ask everyone, since there's so many of us and we only have so much time, to keep your questions as brief as possible so that we can include as many people as possible. Please raise your digital hand or your physical hand. It's easier to see your digital hand because it sorts you to the top of the screen, but I'll try to see the physical hands as well. And I know Mary will help me if I miss anyone. All right, so the first person I have is Susan Garrett at Lathrop, and you are muted, Susan. So unmute and ask your question.
Okay, thank you. I feel so hopeful now. Thank you, Douglas. I wanted to ask what you thought about the Miyawaki little forests. Do you think those are helpful?
Yeah, that's it's the latest craze. Well, Miyawaki was a Japanese man who said, look, if we plant very densely, particularly in urban centers, we can revitalize the soil and you get a whole lot of greenery into a place that had none. And that will support a lot of biodiversity. And he did it in southern areas of Japan, where they've got a lot of tropical growth and worked really, really well. So it's now caught on in this country. We don't have any that are very old. And so by small, I mean, you're talking about really areas the size of a room or maybe the size of your house that are planted very, very densely. Initially, you know, I've planted experiments pretty densely, and I see what happens after 20 years to those experiments. You end up with 2 or 3 trees that have dominated everything, and everything else has disappeared. So I said, well, gee, we're gonna lose all those plants. So why don't you just plant 2 or 3 trees to begin with? But I've changed my mind on that. Because when you plant densely, first of all, you use small plants, which are cheap. You can plant from seed. That's even cheaper. And it grows up so densely that you don't have a weeding problem. All the plants that are there are the ones you put there, and that saves you a lot of energy. It will keep the invasive plants out much more effectively. If you plant 1 or 2 trees, you've got to mow under there, and there's a lot of upkeep to keep those trees happy. You will lose through competition plants over time, but in the meantime, you have supported a lot of biodiversity. And I actually have a new grad student starting this fall who's going to study Miyawaki forest and measure that the biodiversity increases. So we can say, okay, biodiversity is going to increase this much if you do this. I love to come up with real numbers so that people feel even more motivated. So I am a fan at this point. Of course, you got to use native plants now.
All right, anyone else raise your physical or digital hand, and I will do my best to call on you.
Michelle, Dale Labonte has a long question in the chat. Perhaps
Okay.
you could read it or share it.
Sure. I will go ahead with Dale's. It says many organizations like Audubon and many land trusts are logging their forested areas in the name of conservation, which for foresters equals management to produce wood and sometimes to create early succession habitat. Is it problematic to use the term conservation when it has such a contradictory meaning? And incidentally, aren't the backyard national park plots mimicking early successional habitat?
Well, first of all, there's nothing wrong with early successional habitats. There's a tremendous amount of diversity that can only live in early successional habitats. And that is the reason that mature forests that have been undisturbed for 100 years, most of them were logged 100 years ago. That's why they are, if they do it properly, what they're doing is creating a mosaic of mature forest and earlier successional habitats. We are losing a lot of species of birds that only breed in early successional habitats. Things like the golden wing warbler, it's a scrub habitat breeder. And the only scrub habitat we have left is typically power line cuts. So that's the motivation behind it. It's not to get as much board feet out of the area as possible. There are 2 ways to log a forest, to manage it. And that is through I forget the fancy term, but you're taking the best trees and leaving the worst. And that will give you a good harvest once. And then you have to wait 80 years. Or worst first harvesting, where they actually take the worst trees, always leave the best trees. They're going to supply the seed that regenerate that forest. Then you can sustainably harvest wood from that forest essentially forever. There are indigenous tribes in northern Wisconsin that have been practicing worst first forest management for over 100 years. They now actually have more woody material in their forest than they did when they started because of that management. So logging in and of itself does not have to reduce biodiversity. You can wreck your forest if you don't do it correctly. Remember that not long ago, 8, 9, 10,000 years ago, we had a lot of large Pleistocene mammals in North America. We had giant sloths that could reach up 18 feet. We had 3 species of woolly mammoth. We had there were 44 species of rhinoceros on the planet. There were huge things, and they were keeping our forests much more open than they are now. So it's the removal of disturbance. Many of our forests are fire climax communities. We don't prevent fire. We don't tolerate it anymore. So they get so densely overgrown that what we think is normal, the very dense forest, actually is an aberration these days. A much more open savanna-like landscape supports a lot more biodiversity. So that's why they're doing it. I agree they have to do it correctly, but it's not necessarily bad.
Thank you. Larry from Hanover.
Thank you so much. This is just fantastic. Very exciting. I think the word you were thinking of was highlining forests.
High grading. You're right.
High grading, yeah.
Yeah, that is the word.
But yeah, I also want to thank you 3 times over for your comments about leaves and leaf raking. I've been fighting a 1-person battle about those dingle-dangle leaf blowing machines.
Yes.
Anyway, so thank you for the rationale and the reasoning behind that. Is terrific. My question is simply, aside from, I have one short question, and that is, can we have clone of you to have around all the time.
One of me is
Sure.
enough, believe me.
Short of that, I do want to ask about bee collapse, bee colony collapse. I recently heard that that may be reversing, and I don't know whether that's actually true or what you know about that.
No.
I don't know anything about that.
No.
I was on a USDA panel, I don't know, maybe 12 years ago. They came up with $4 million they were going to provide to bee people to study colony collapse disorder. And I was the panel manager, and there was one of the premier apiculturists from Cornell. You know, I said, I'm not a bee guy. So even though I was managing the panel, that was just administrative. And I said, what is this colony collapse disorder everybody's talking about? And he said, it's called CCD. He said, it's not CCD, it's PPB, piss poor beekeeping. So we do everything wrong for our poor bees. We cart them for thousands of miles all over the country so they can pollinate single crops. They want multiple species to pollinate. Single sources of pollen are not healthy for them. We inbreed them. And there's not enough forage out there. We've removed flowering plants all over the place. So we've stressed them. We've also introduced several really important challenges, varroa mite, a number of species of viruses, and people have been working on it a lot. Whether it's reversing at this point, I haven't heard. Maybe it is, but I haven't heard.
Michelle, someone was shaking her head right next to the former.
Yes.
Yes. Is she still with us?
Yes.
Anita?
Alice Nicholson, did you want to add your comment?
There was an interesting article about that in the Washington Post, I believe, quite recently. And bee colony collapse is still happening. However, the population of honeybees in this country is enormous now because in Texas, they're growing them, basically have bees as a crop, and they don't expect a hive to live for more than a year, and they're constantly replacing the way you do with an annual crop.
Okay, hadn't heard about that. Thank you.
Wow. Okay.
I have a question too.
Oh, go ahead, Alice, with your question, and we'll go to Anita.
My question is, can you get away with no mow under tree canopies instead of having to plant stuff? Because we can't afford to plant stuff under all of our keystone oaks and things. We need basically either we stop mowing the lawn or we continue to mow the lawn.
Right. Yeah, that's a great question. And yes, you can. Don't mow under the canopy. Your tree will love it. You know, what we do is we ride with our big mowers under our trees and we compact the soil. There's two things that the tree doesn't like it because it hurts the root systems when we compact the soil. But it does another thing. Those caterpillars that all the birds are eating, most of them develop as larvae in the tree canopy, and then they drop from the tree and they try to pupate in the ground. If it's compacted, they can't get underground. So having grass right up to the tree is very hard on those caterpillars. If you simply stop mowing and let the soil loosen up, then the caterpillars will be able to get underground. The only objection that people might have is that it looks like it's not mowed. So it's an aesthetic thing, but ecologically, it's great. And the bigger the area around your tree, the better.
Thanks.
All right, Anita, you're next.
Okay, yes. First, I wanted to comment on Alice's Texas article. Yeah, the reason that Texas are raising so many bee colonies is because it allows them a tax break that farmers get because it's considered a crop, so it's all about money. And it allows people who aren't actually farmers to call themselves farmers. And then my question was, you mentioned that when you replanted your lawn in your new home, it was easy to get rid of the invasives because your wife did it. How did your wife do it?
I helped her a little bit in the beginning. We had some big ones. So you can pull them, you've got to kill the root system. You can pull them out. So originally there weren't any trees around. So I actually had a tractor and I wrapped a chain around the base and we could pull out the big multiflora rows. And but she has stuck with it with her little hand whacker, and she whacks out the roots as they come in. She won't use herbicide. But some of the, the bigger autumn olive that we actually had to saw down, I don't want to spray because you always hit non-targets. A lot of times underneath that multiflora rose or places the deer can't get, that's where the baby oaks are. And if you spray, you kill them too. So we remove the invasive and then I paint the stump with an herbicide and that kills the roots. Then I only have to do it once. If you just simply cut it, it will come back forever. And none of us are going to live that long. So that's what we do. But we're at the stage now where it's simply monitoring the seedlings that come in every year. And that's easy with it's called a little hand matic, just whack, whack, and out they come. And she spends hours out there every day. Just like that's her interaction with nature. She loves it. So
Thank you.
Yeah,
All
thank
right,
you so much.
Dorothy and Charlotte from Oberlin, and you're muted, so go ahead and unmute. Go ahead and unmute Dorothy and Charlotte. Dorothy and Charlotte, we can't hear you. You need to unmute. There they go.
Our native populations, the existing native cultures, a good source of sustainable living. And some of this includes things like slash and burn agriculture. Are these usable procedures? Some of the, like in California, of course, the burning of forests is one of the native solutions. Are there other native cultures with good solutions for us?
Well, yeah, burning in fire climax communities has been one of the approaches that indigenous people have used all over the world, including in the East. The Eastern tribes managed our eastern forests all the time. What they were doing were managing for deer populations, and they wanted to keep it open enough that the deer were numerous enough. So of course, we stopped all that and everything closed in and changed everything. So proper fire management, ground fires, not canopy fires, at ecologically appropriate time intervals is a very valuable management tool. It's a valuable management tool for our prairie ecosystems. Slash and burn is typically what tribes do in tropical areas. Those are small plots, just a few acres. And then they plant some crops, and the soil down there is very, very poor. So they only get 1 or 2 crops out of it, and then they move on and slash and burn in another area. But that area grows up very quickly. Slash and burn works when you have a small population of people doing it. It does not work for millions of people because the earth is not big enough. So it's a technique that they still use, but only on a very limited level in really pristine areas.
Okay, thank you. Next up, we have George from Collington.
Hello, Doug. Thank you for giving so many great talks all over the country. You gave a good one in our seminar up at Oswego, where we have our oak tree growing project, and we appreciate you very much. And I want to see if you would talk a little bit more about keystone white oaks and how to plant them, including maybe even the idea of free planting without protection, fencing thing. Thank you.
Okay, well, thanks for those compliments. There's in the East, well, all over the country, we've got groups of oaks, taxonomic groups. There's the white oak group. And that includes white oaks and post oaks and chestnut oaks and a few other species. Those acorns germinate in the fall. So they fall in the fall and they germinate pretty much right away. So if you're going to plant a white oak, you want to get that acorn wherever you want it. You can just lay it half on the ground and the radical will go straight down, but that has to happen in the fall. You can't store them in over the winter. The red oak group, which includes red oaks and pin oaks and black oaks and scarlet oaks, they germinate in the spring. So you can gather those acorns as soon as they fall and put them in the refrigerator so that they overwinter, and then in the springtime, plant them where you want them. The problem of putting them out without any protection, that's exactly what I did when we moved into our property. There was nothing here, and that included no deer and no mice. And I put the acorns out, and they did great. There was very little herbivory on those acorns. Today, we've got so many things living here that if I put an acorn out, it is eaten right away. So what I do is put them in a flower pot and let them germinate in the flower pot in a protected area where the deer can't eat them, where the mice can't get to them. Let them get, about this tall from the first year, and then I plant that. But at my house and in so many other places, the deer population is so high. If you don't put a fence around that, a cage, the deer will get it. It's unfortunate, but that's the way it is. So as a matter of fact, it's a serious problem in our forest. There's no oak regeneration because the deer are eating them all. The real solution is to reduce the number of deer. So does that help?
Yes.
Hey, we have one more question from Mary Duncan at Crosslands. Mary, can you hear us? We can't hear you, Mary, for some reason.
I think
It's
she's
okay. Okay. We can put it in chat maybe. All right. Well, we have time for maybe one or two. Would anyone like to raise their hand? Okay. Just let me check the screens. I have two screens here. Oh, I do. I see Margaret from Hanover. And Margaret, you'll need to unmute.
I just wondered whether putting a circle of peat moss around the base of the oak tree, is that good or is that bad?
It's bad for two reasons. It's not going to hurt the tree, but peat moss, we're trying to discourage the use of peat moss because they mine the peat moss from the big peat bogs up in Canada and other places. It is a major carbon storage source right now. There's more carbon stored in those peat bogs than so many other ecosystems. So we're trying to end that. We want to leave that carbon in place. And the other thing is, it's not nearly as good as the leaves that come from that tree, and that would make a much better mulch. Now, people say, well, that's not very neat and tidy. There's somebody sent me a picture of wooden designs. I don't know how I can draw it for you, but like in an octagon of a wooden platform, maybe eight inches tall, and you put the leaves in that, and you put them all around your tree. So it's very ornamental, it's very attractive, and the leaves stay in there, they don't blow away. That might be a good solution for people who just don't want messy leaves under their tree. It would accomplish all the goals you want. So I have to look into that. And
yes, I'd love to see a photo of that.
Yeah, I did see a photo of it. It was great. So
all right, two more. I have the Theo and Deb, and then Merle.
So is it our turn now?
Yes, it is.
Well, hi, everybody, and thank you, Doug, for that presentation. It was very inspiring and thought-provoking. And one of the things I thought of was, here we all are living in residential communities that have quite a bit of acreage and some trees and flowers and like that. What are we doing at our places to get them to do what Doug says? My question.
You know, I've talked at a number of retirement communities, and who you really need to talk to is the owners and the management, the landscape managers.
And
There's a lot of
now-
inertia. They do it the way they've always done it, and you need to say, hey, let's increase the percentage of native trees when you have something fall down. And with our storms these days, they fall down all the time. Think carefully about the plant choice. And you know, I haven't gotten a lot of resistance. That there's some support for this, but most of the problem is ignorance. They do not know that they're not doing it correctly.
Good. And that's, I would like to say, if anyone has a successful project, let me know, because if we put that in our newsletter, then it puts a little peer pressure on the other communities
There
to
you
do
go.
the same
That's a
thing.
great idea.
Okay. Before we go to Merle, there's a question from Mary, who wasn't able to live. She said, can you explain the importance of ground dwelling bees as pollinators and what conditions they need to prosper?
Okay. We have the honeybee, but we also have 3,600 to 4,000 species of native bees. 70% of them nest in the ground. So they are extremely important in terms of pollinators. Now, some people get upset that there's bees nesting in the ground. They think they're going to get stung, but these are solitary bees. It's a single female taking care of her young, and she's not protecting a hive. You can pet them and they won't sting you. So don't worry about that.
True.
You heard that at a SAFE meeting.
So they are very important. What do you do to encourage them? They like little bare patches of ground. I say that hesitantly because I don't want you to, you know, get the bulldozer out and make giant bare places, but places where you maybe scratch the leaves away. They like a slight southern slope because it warms up first in the spring. And they like soil that is relatively easy to dig in, although there are species that will go right down through the hardest clay. And you know, areas where you're not gonna mow or use insecticides or water, because you can drown them very easily. It's an area you're going to put aside if you know you've got some ground nesting bees. The easiest thing to do would be to, right now in the early spring, walk around your property and find some that exist, because that's the condition that they want. And then maybe you can expand that condition so that you can have more of them. But they're extremely important. We want to encourage them anytime we can.
Thank you. Merle, you are next.
Yes. Hello, everyone. And Doug, this has just been extraordinary, with about 1,000 explanation points after that. Thank you. Every time you speak, you bring up something new and something significant and important. And I just thank you so much for all you shared. And I would like to extend your challenge, or I should say repeat your challenge to all of us. We represent many campuses, many different parts of the country here. And on our campuses, in our communities, we have committees, we have, you know, organizations, groups that are responsible for our woods, our meadows, for greening our campuses, for managing our landscapes and so forth. And so I just urge everyone here today to get back to those committees. I know many of you are all parts of them. And if we can accept this challenge to plant keystone plants, even just one, as Doug mentioned, but many, many keystone plants, and push for the pollinator gardens and the pot gardens on your doorstep and so forth. I just think that would be a wonderful start for us to really, you know, build on our hope and increase our chances to feel like we are actually doing something that needs to be done. So to all of you, see what we can accomplish.
Merle, there could not be a better note to end on. And Doug, thank you for the generosity with your time. This is an unusual meeting for us, an hour and a half with one activity, but it could not have been more of a joy and a challenge. So blessings to all. Be hard at work in this next month. We'll see you the first Thursday of May. And may it really be spring by then.
Yes.
All right. Well, thanks very much, everybody.